All right, let's play around with reference angles a little bit. So look at this. The question says, what are 3 other angles in standard position that have the same reference angle of 30 degrees? Okay, well here's my first one. This is pretty obvious. There's my theta r, my reference angle of 30 degrees. Now, where else could you have a reference angle of 30 degrees? Well, honestly, right here. There's another reference angle of 30 degrees. Oh, well, that's pretty easy to figure out. Give me a couple more. Well, there's one here. Look at this, 30 degrees. Because think of the definition. It's always 30 degrees with the x-axis. So I'm going to bring this guy up here. What's our last one that we can have? Our last one we can have is right down here of, again, 30 degrees. Those are all reference angles of 30 degrees. But my question was, what is their standard position angle? Well, this one, standard position angle, is the same as the reference angle. That's 30 degrees. Okay, so there's your standard position angle. No problem. But my question is, remember, what standard position means, start here at the initial arm and terminate there. Interesting. What would that angle be? Well, all the way to here, of course, is 180. Just take 30 off. 180 minus 30 degrees, that would be this angle here, okay, which would give you 150 degrees. That would be 150 degrees in standard position. See how it works? Pretty neat. Look at the next one. Starting here, going all the way through the 180 and 30 more. So it'd be 180 now plus 30. Interesting. Works out to be an angle of 210 degrees. It would be 210 degrees in standard position. You see how all of this works? It's kind of interesting. Notice how a lot of this is based on this quadrantial angle of 180 degrees. It's either subtracting 30 from it to get it less, or adding 30 to it to get it more. Interesting. Does it work on the other side? Well, think about this. This goes all the way around here. We know that all the way around is 360 degrees. Of course, we're not going all the way. We've got 30 degrees of a reference angle that we have to take off here. So we're actually at 330 degrees. That's our standard position angle. Isn't that interesting? Now, I know what you're thinking. What's the point? Well, let's write these angles out again. 30 degrees, 150 degrees. What was the next one? Oh, 210 degrees and 330 degrees. Let me show you something really, really amazing on the calculator. Check this out. If I wanted to do something like sine of 30 degrees, bringing up, you know, the old sine 30 degrees, that's from Math 10C. Watch the answer. I guess 8.5. I'm curious, what was the other reference angle? The other reference angle was, oh yeah, there it is, 150 degrees. Okay, perfect. Watch this. Sine of 150 degrees. Watch this. 0.5. Woo! Isn't that interesting? Well, what was the other reference angle? The other reference angle was here, 210. Okay, 210. Sine of 210. Huh. Wonder if it's 0.5. It's actually 0.5, but it has a negative in front of it. I wonder why. Well, look at these. Look, 30 and 150, 30 was above the x-axis. So was 150 above the x-axis. Interesting. 210 was below the x-axis, which gave it the negative. Isn't that interesting? I bet you if I type in 330, can you predict what the answer will be? You know it's going to be 0.5. You know it's going to be 0.5, but it's below the axis, isn't it? So if it's below the axis, I wonder if it's going to be negative 0.5. Well, only one way to tell. Here we go. Sine of 330. Let's see if it's negative 0.5. Here it goes. Ready? Boom. Oh my goodness, it is. So that's one of the reasons why we do reference angles, because every every one of these angles, this one, this one, this one, and this one, all have a reference angle of 30 degrees, and their signs are all the same. The negative, I'll explain in a couple of podcasts from now.